In this video, we will take a look at how to describe the central location of quantitative data. If we don't have access to all the values of a data set, we can get a good idea of what the data looks like, or at least where the center of the data is, just by knowing what the mode, median, and/or mean is of the data. The mode of a data set is the value that occurs most often. The mode should be one single value, although sometimes we can have data that is bimodal, which means it has two modes. In dataset number 1, the mode is 4 because that is the value that occurs most often. It appears 3 times, but the mode is the data value itself that appears most often, not how many times it appears. In dataset 2, both the numbers 3 and 4 appear the same amount of times, so we can say that there are two modes, 3 and 4. Although technically the mode is supposed to be one data value that appears most often. So if there is not one single value that appears most often, we could always say there is no mode. Both answers could be considered correct. We don't want to go crazy with too many modes of a data set. In dataset number 3, the numbers 2, 3, 4, and 5 all appear twice. But I'm not going to say that there's 4 modes. That defeats the purpose of trying to summarize the data with one number. So I would say that there is no mode in dataset number 3. The median is the middle value of an ordered data set. In dataset number 4, the median would not be 2 because the data is not in order. I can order the data from small to large or large to small, it doesn't matter. But once it's in order, I can find the median. Putting dataset number 4 in order gives us a middle value of 4, which is the actual median for that data set. It gets a little trickier when there's an even number of values, because with an even number of values, there's not just a single middle value, there's actually two middle values. If that happens, I need to take the average of the two middle values, and that will be the median. You can see in dataset number 5 that there are two middle values, 3 and 6. So I average 3 and 6 together to give myself a median of 4.5. Similar to midpoints, I'm never going to round the median. If it's a decimal, I will just leave it as it is. The median does not have to be one of the original values of the data set. You may be familiar with calculating a mean. To calculate a mean, I need to add up all the data values I have and then divide by the number of data values I have. So in example 6, to calculate the mean, I have to add up the numbers 2, 4, 5, 8, and 11, and then divide by 5. I divide by 5 because I have 5 data values. When I do that calculation, that gives me a mean of 6. Many of the formulas we are going to see going forward in this course utilize mean of data. We need to become familiar with the symbols that will be used in those formulas. In math, the Greek letter sigma, this is the capital sigma up here, it's used as a notation which means to, quote, sum the following. If I see that symbol in a formula, it means I have to add up anything that follows after it. The variable x is usually used to represent any data value. And the variable n is used to represent how many data values we have. We always like to delineate between sample data and population data. So when I use a lowercase n, I'm referring to the number of data values in sample. And when I use a capital N, I'm referring to the number of data values in a population. So when we calculate a mean, we usually start by adding up all the numbers we have, and then we divide by how many numbers we have. If I were to put that thought into a formula with our new symbols, sigma x would be the representation of adding up all of our data values. and then we would divide by n, since n is a representation of how many data values we have. When I complete that calculation, I have a mean, and I usually like to distinguish whether I have calculated the mean of sample data or the mean of population data. The mean of sample data is represented by a symbol called x bar, and the mean of population data is represented by the Greek letter mu. All of these fancy symbols and formulas doesn't change the fact that I'm simply adding up a bunch of numbers and dividing by how many data values I have. But in the future, if I am ever told that x bar equals 6, I will know that we are talking about sample data. And if I am told that mu is equal to 6, I will know that we are referring to population data. So this is a discussion we will continue next week.